concepts. Whenever you're talking about the more concept, you have to know what is the more. First of all, you have to know how to define what is a more. Na ukishajua kuidefine more ni nini, unaeleza ni nini. Some of us, we've been trying to go to the shop to buy something. You cannot buy a single sugar, but we buy a sugar in terms of kilogram. We always go to the shop to buy shoes, not a single shoe. We buy a pair of shoes. We always go to the shop to buy dozen of something. A dozen of something means there are some sort of the specific quantities which are there. And that makes you to say that this is a dozen of, this is a pair of shoes. Kwa tunapoenda dukani, tunanunua, hatununui sukari moja. Hatununui punje moja ya sukari. Tunanunua kilo moja ya sukari. Tunapoenda dukani tunanunua viatu. Hatununui kiatu kimoja. Tunasema bana nimenunua pair ya kiatu. Tuko pamoja? Kwa hiyo tunapoenda dukani unasema kwamba nimenunua katoni moja. Nimenunua dozen moja. Nimenunua pair moja ya kiatu. Manake kumbe a pair represents a number of quantities. A certain number of quantity. That is a pair. Of the same item, a dozen now represents some amount of things. I mean the specific quantity. Or the specific number of items. That is a dozen. For mfano, in normal life we say a dozen consists of 12 items of the same kind. That is a dozen. Kwa nikisema dozen ina vitu 12 vya kufanana. Nikisema pair ya viatu manake ina viatu viwili vya kufanana. Kimoja cha kushoto, kingine cha kulia. That's a pair. Nikisema gross na maanisha kitu fulani. Idadi yake inakuwa ni hivyo. Sasa hii inatumika kwenye vitu vingi ambavyo it is so difficult for you to count as a single item from 1 up to 10. Maana kwa mfano kuhesabu kwa dozen inakuwa ni rahisi zaidi kuliko kuhesabu kwa moja moja. It will take you time. Because we do this in order to simplify things. Example, I need a pair of shoes. Somebody will definitely understand what am I talking about. I need a dozen of exercise books. Manake mtu atanielewa nini ambacho nazungumzia. How many items are there of the same kind? Now I have 12 items of the same kind in one dozen. Kwa hiyo, whenever you're talking about a gloss, maybe you are talking about 144 items of the same kind. Kwa nikisema bana mimi na gloss moja, kwa yule ananielewa kwamba kumbe ana vitu 144. Kwa nikihesabu I have 5 glosses. Tayari mimi nachukua 144 mara 5 napata how many things do I have in my hands. I have 12 dozen means 12 times which 12 dozen times 12 means how many items do I have in my hands. So that was designed to make or to simplify the counting expression of the things which are many for the same time. Sasa, this is applicable also to the atoms, to the particles, to ions, or to the matter itself. Matter is made up of the small particles which are called what? Atom. You cannot count for the same time. You will spend a lot of time just counting it. Kwa kumbe hii inakuwa applicable kwenye vitu sasa ambavyo vinaitwa substance, as an atom, as a metal, as a sodium, whatever the case it is. Kwa sasa hii ndio ina develop more concepts. How many particulate entities are there? Therefore, in the same way, substance is made up of millions of particles that are there so as to make that substance happen. This is a piece of chalk. It is made up of millions of particles that are there. We're talking about a stone. We're talking about a woods. We're talking about anything else. It is made up, a substance made up of millions of particles that are there. Now, it is so difficult for us to count those particles. And that is why we use this concept called the Moore concept. And that is why we use this concept called what? The Moore concept. Now, definitely, the Moore are the unit of measurement. The Moore are the unit of measurement. That is the first part to discuss. Now, the Moore of a substance is the amount of substance which contains as many entities. As many entities. Which contains as many entities. Those particulate entities may be atom, may be molecules, may be ions, or may be particles itself. Kwa anaposema kwenye language ya chemistry, particulate entities, anamaanisha it may be atoms, may be molecules, may be ions, as there as carbon atom in 12 grams of carbon 12. Are there carbon atoms in 12 grams of carbon 12. Carbon 12 is taken as the reference. Tunanielewa vizuri? Nikisema is taken as the reference, you cannot understand me. Tunapima maji, sawa, pamoja na kwamba tunatumia volume. Lakini unaweza ukapima maji kwa kutumia ndoo. As local way to do it. Kwamba unachota maji unaweka kwenye umeweka ndoo ngapi bana? 5. Kwa nimetumia reference unit kama ndoo hii nimeitengeneza ina lita 10. Kwa maana nimechota ndoo 10. Kwa maana nimechota ndoo ya lita 10 ziko 10. Kwa maana hiyo nina lita 10 mara 10, I have 100 liters. Now I've taken the bucket as the reference. Instead of counting every time, 1, 2, 3, 1, 2, 3, 1, you keep on wasting your time. And that's why the scientists, and especially chemistry, they designed this, what we call it, the Moore concept. And that is why by definition we say, Moore of a substance is the amount of the substance. Ni kiasi cha kitu which contains as many entities. For example, we have atoms, we have molecules, we have ions, as there are carbon atoms in 12 grams of carbon 12. Now, this is taken as the reference. Now, the SI unit of this one is mole. And it is abbreviated as MOL. MOL. That's what I can tell you. That is the first thing. Now, whenever you're talking about mole, if now you have 12 mole, you write 12 mole like this one. This is an abbreviation that you would have written. And whenever you have written this one, you mean amount of the substance. It is called amount of the substance. Inaitwa amount of the substance. And that is from the definition. And therefore, the second thing you have to discuss is called Avogadros constant. Now, you have to understand how can you use this Avogadros constant? What is the relationship between Avogadros constant and the amount of the substance? How are they defined? How we can calculate it? How we can determine it? And it is very simple. Now, the measured mass of an atom of carbon 12 is 1.9927 times 10 power negative 23 grams. This is the measured gram of carbon 12. Now, the measured mass of carbon 12 it seems to be like this one. Now, to find the number of atoms in 12 grams of carbon 12, why do we call it carbon 12? This is all about isotopes. We have carbon 12, we have carbon 13, we have carbon 14. That is isotopes. According to the what? Isotopes principle. We learned about isotopes. So I don't wonder, I don't expect to see you now wondering about isotopes while we learned about it. Now, we're talking about carbon 12. And we are not talking about carbon 13 and carbon 14. We are no longer about talking those things. But now what we are talking about is what we call it carbon 12. Then in order to determine, to find the number of atoms which are present in 12 grams of carbon 12, so we divide 12 grams by the measured mass. We divide 12 grams by the measured what? Mass. So we take that 12 grams of carbon, we divide it by the measured mass. Means what? This is approximately the mass of one particle of an atom. The measured mass of an atom of carbon 12 is this one. Means what? It is approximated that the mass of one atom of carbon is 1.9927 times 10 power negative 23 grams. Now to find how many particles are there, or how many atoms are there in 12 grams of carbon. Just like now, let me say something. You have 12 kilograms of maize. But every single maize, they are within the bags, but every single maize, a single maize, I don't know how do we call it, has got 2 grams. But you have 12 kilograms of maize bag. The bag of maize is consisting of 12 kilograms. Now, in order to know how many maizes are there, you have to take that 12 kilograms, you divide it by 2 grams. So as you may know, how many are they? And that is what I'm talking about here. If now the measured mass of an atom of carbon 12 is seen to be this one, of an atom, how many atoms are there in 12 grams? In 12 grams. But remember, for a single gram, for a single atom of carbon 12 is this one. But now we have been given the 12 grams of carbon 12. Now that is why we divide the 12 grams by the measured mass. By the measured mass. And that is what mathematically here it is. Kwa kimahesabu hii hapa comes to this way. It was negative. According to the exponent, this becomes what? Positive. Right here. Then we take this divided by this one. Then we have this one. Then mathematically gram and gram cancel out. Then we remain with this one. And this is called, now in short, we have 6.022 times 10 power 23 atoms in 12 grams of carbon 12. And because we have taken carbon 12 grams of carbon 12 as the difference, this value is known as Avogadros constant. That value is called Avogadros constant. And then wherever you go, if now you are looking for the Avogadros constant, don't be surprised. This is what we're talking about. This Avogadros constant may be atoms, may be molecules, maybe ions that are so far we're talking about particulate entities. Particulate what? Entities. Now those particulate entities that we're talking about here, as I said before, we have atoms, molecules, and ions. Therefore, this is what we call it the Avogadros constant. Have I made myself clear? Are we together? But therefore, Avogadros, not. Remember, this means what? From here we have said, we have taken this atom, mass of one atom of carbon 12 is this one. So as we may know how to determine how many atoms are there in 12 grams of carbon 12. And that is what we have done. This implies what? 1 mole of any substance contains these particulate entities. 1 mole, that is to say, if now you have 1 mole is equal now to 6.022 times 10 power 23. It may be atoms, it may be ions, or it may be molecules. And that is what I've written here. 1 mole of any substance contains 6.022 times 10 power 23 particulate entities. And those particulate entities may be atoms, may be molecules, or ions. Kwa nikisema particulate entities, na maanisha hivi hapa vitu. Kwa it depends what kind of the thing am I talking about. Naweza nikawa nazungumzia molecules, naweza nikawa nazungumzia atoms, naweza nikawa nazungumzia labda ions. Are you together? Yes. Now, by using this Avogadros constant, we are capable of converting the number of particulate entities present in a sample to the amount of the substance. I have my sample in my pocket. I have sample in my hand. I just want to know how many number of atoms are there in my hand. I definitely use this concept to determine how many atoms are there. And that's why we say converting the number of particulate entities present in a sample to the amount of substance. How many atoms are there in my hands? How many molecules are there in my hand? How many ions are there in my sample? I definitely use this concept called Avogadros constant to determine how many are there. And definitely simple because number of mole, that is the amount of the substance, is equal to number of particulate entities over number of particulate entities per mole. Number of particulate entities per mole in a chemistry language, that is called Avogadros constant. And remember, we have said it is here. 1 mole of any substance contains 6.022 times 10 power 23 particulate entities. And those particulate entities may be atoms, molecules, or ions. And that's why from the formula here, I've not written Avogadros constant directly, but I've written something called the number of particulate entities per mole. Number of particulate entities per 1 mole means 1 mole is equal to Avogadros constant, which is equal to 6.022 times 10 raised to power 23 particulate entities. Particulate what? Entities. And what are those particulate entities? I mean of atoms, molecules, ions, or particles. And that's why somewhere you may be asked, determine the number of molecules, determine the number of atoms, determine the number of particles, determine the number of ions. There is no difference. But the only difference is that we're talking about particulate entities. Have I made myself clear? Yeah. Are we together? Yeah. Now, in short, after I've written this formula, in short, this is what I would have written here. Small n is equal now to capital letter N over LOA. Small letter n represents the amount of substance. Capital letter N represents the number of particulate entities. Those are the atoms, molecules, or ions. And LOA represents Avogadros constant, which is it is constant as it is named. Yani jombayo iko hivyo hivyo, amka lala sinzia hivyo hivyo. Sawa? Are we together? Yes. Are we together? Yes. Now, this is the formula. Now, in more concept, we have 3 formulas that we are going to use to determine the amount of substance. The first one is all about Avogadros constant, and the second one, I don't know where is it, but we are going to check it. Now the first formula, this is how you can determine the number of substance and the amount of substance. But this only can be used to determine the number of substance and also can be used to determine the amount of the substance. In case you have how many atoms are there, how many ions are there, how many molecules are there, you can use this to determine what we call it the amount of the substance. Now we have 3 formulas on how we can determine the amount of the substance. But on the whole topic, we have 4 formulas that are used to determine the amount of the substance. Now this is the first one. Amount of the substance is equal now to number of particulate entities over Avogadros constant. And now, if now you use some thing we say, my dear here, tap. If now you close tap, you find capital letter N is equal to small letter n multiplied by Avogadros constant. This is according to mathematical, close tap. Now this is the form and different is used. Now let us see 2 examples here. Example number 1. How many moles of nitrogen gas are there in 2.2 times 10 power 12 molecules of the gas? Let us move the tractor. We are moving the tractor. The tractor somehow is so difficult to move, but we can start it. Now, how many moles of nitrogen gas are there in 2.2 times 10 power 12 molecules of the gas? So from the question we've been asked to find how many moles are there. We're talking about amount of substance. Is it so? But we have something called the number of molecules that are there. But remember, Avogadros constant is always there because something constant. It was determined and it is there, as we have seen it before. So from the question, we have capital letter N that represents how many molecules are there. We have 2.2 times 10 power 12 molecules. And then we have LN, that is Avogadros constant, 6.022 times 10 power 23. That is molecules. Then, what are we talking about? Amount of substance is equal to what? But remember, we have said amount of substance is equal now to capital letter N. That is the what thing? Number of substance over Avogadros constant. Then, number of molecules we have, it is 2.2 times 10 power 12 molecules. Then over Avogadros constant 6.022 times what? 10 power 23 molecules also. Mathematically they cancel out. Then we start simplifying. Mathematically this and this. Then we remain with 10 power 22. 11. Is it so? Yes. Now, here, 12, then there will remain what? 11. Therefore, mathematically, we have 2.2 over 6.022 times. Remember, mathematically, this will be taken to the numerator. Instead of leaving it here, we take it to the numerator. That becomes 10 power negative 11. Then after dividing, we get 0.365 times 10 power negative 11. But mathematically, this will be taken this one. This is mathematical, like in the standard form. Is it so? Yes. Then we have it is equal to 3.65 times 10 power negative 12. Now this is what we're talking about more. So in order for you now to determine how many moles are there, you have to know what kind of the question am I talking about. If now I'm talking about the number of molecules which are there, I have to use this formula. But in case now you've been given the mass of the substance, we have the other formula. In case now you've been given the volume of the substance, now you have the other formula. And that is why I've said we don't have a single formula to determine the mass, the amount of substance. Hatuna moja tu, kwa zipo nyingi. Inategemea na aina ya swali ambalo unaambiwa. We learned about exponents. Watu wanauliza hii hapa 12 toka wapi? Tukisogeza hii hapa sinasogea na 10 power negative 1. Sasa tunakuwa na 10, we have 10 power negative 12 times 10 power negative 1. Mathematically, we always add these exponents because of multiplication law. Then we have 10, then negative and negative, we have negative 12. The same applied here, we have positive and positive. Mathematically, we would have cancelled it 12 times, and then we have cancelled 12 times. So that we remain, and the denominator we have this one. That is a mathematical concept, not according to chemistry. Now let us go for the second example. How many moles are there in each of the following molecules, the following particulate entities? A, we have 214 atoms. B, we have 7.5 times 10 power 50 molecules. And C, we have 2 ions. So if now we start with A, we have A, that is equal now. A, we have number of particles, we have 214 atoms. But remember, Avogadros constant is there as constant value with 6.022 times 10 power what? 3. You get it? It may be atoms, may be molecules, may be what? Ions. But now we're talking atoms. Now we have this one. Then we are looking for the number of moles. Amount of substance. N is equal now to N over L N. Now, remember N is number of particles, which now is 214 over LN 6.022 times 10 power 20 what? 23. Now, mathematically, this is taken to the other side. You got it? Then you have 214 divided by 6.02 times 10 power negative 23. Now these are called atoms. Now you may divide them according to mathematics. So you take this one, divide this one, multiply this one, you get it. Then if now you're talking about molecules, the same apply to it. Number of amount of substance is equal to N, capital letter N over LN. Now N, we have 7.5 times 10 power 15 molecules. Divided by LN, 6.022 times 10 power 23. Mathematically, this comes out. Then you remain with 7.5 over 6.022 times, now 23 by 50 years. Minus, we remain with what? 27. Times 20, 10 power 27. Kwa hiyo mahesabu tu kwamba nachukua huyu hapa na gawanya huyu hapa, hawa na apply exponent law. Wanajiengua, wanabaki anaibaki. Hawa na gawanya tu hesabu ya ugawanya. This is all about division. Decimal divided by decimal. Standard 5, 6, 7 mathematics. Not for Form 1. Not even for Form 1. Have I made myself clear? Yeah. So this is the way we can determine. Therefore, after that, you take 7.5, you divide by 6.022 times 10 power 27. Now, we're talking about it. This is what we call. So I mean the that here. This is not molecules, it is mole. You understand? Because the question is that we need to determine the what? The number of mole. Now here it is what? Mole. But the same applies here. If now you're talking about 2 ions, the same case. But all in all, what I can say, this is the formula that I've been talking about. In case now you've been given the number of mole, and Avogadros constant is always there. You've been taught to determine the number of particular changes which are there. Use this formula. But in case you've been taught to determine the amount of substance, while the number of particles that are there, and the Avogadros constant is always there, you use this formula to determine it. And therefore, to conclude this section, we say there is a relationship between amount of substance and the number of particulate entities which are there. And also Avogadros constant. In short mathematical, I would have said that the number of particulate entities are directly proportional to the amount of substance. Why is it directly proportional? Because there is a proportionality constant. And that proportionality constant is called Avogadros constant. Are you together? Yes. There any questions so far? Yeah? Yeah?